Hello and Assalamualaikum. My name is Mohammad Isyraqi Bin Mohd Disa and I am going to presenting on lab 1 operational amplifier. At first I am going to present which is inverting operational amplifier. Here is the value, the calculated value for gain negative 4.7. This is calculated value for Vout 4.7 volt. Here is the circuit for inverting operational amplifier. The green color is for V in, blue color is for V out. We are using 15 volt of V source. We are using RF value 4.7K and we are going to stimulate. As we can see, V out we get 4.66, which is slightly the same with calculated value 4.7 volt. And for value for gain, we should divide it with negative 988.56 divided by 4.66 divided by negative 988.56 and we get negative 4.69, which is slightly the same with calculated value, which is negative 4.7 gain. And for the second one, we're going to change with 10 kilo ohm RF value. We're going to stimulate and get the value. For the V out we get 9.98, which is slightly the same with calculated value, which is 10 volt. And gain we should divide 9.98 divided by negative 990.32 and get negative 9.930, slightly the same with calculated value. For the third RF value, we are going to use 3K kilo ohm of RF value. Stimulate it. As we can see, V out we get 13 volt and got clipping on the peak of the graph. And again we get for V out we get 13.005 for V out, and for gain we should divide it with 13.005 divided by negative 993.13 and get slightly the same with what I get at the first circuit. Simulate negative 13.028. I am going to answer for question number 1. Why the output waveform has been clipped? Output clipping can be caused by exceeding the input common mode voltage range or the input differential voltage range of the amplifier. What I can explain from the graph, we are for 33 kilo ohm, there will be clipping on the V out value. V in is still the same, but on the V out got clipping on the peak of the graph. So I am going to answer for question number 2. Why is it called an inverting amplifier? It is called inverting amplifier because the operational amplifier changes the phase angle of the output signal exactly 180 degrees out of phase with respect to input signal. It provides an amplified signal which is out of phase with the applied input. What I can explain from the graph, as we can see, the negative, we insert the soft positive invert. So we are getting negative wave, but here is the negative wave, but we are getting the positive phase of the output. That's why we call it inverting amplifier. So I'm going to presenting on non-inverting operational amplifier. Here are the value of gain 5.7 and we out calculated value is 5.7 also. Here is the circuit for non-inverting amplifier. The green color is for V in, blue color is for V out. We are using 4.7k ohm. We are going to stimulate. Blue color for the V out. So for V out we get 5.67, which is slightly the same with calculated value, which is 5.7 work. For the gain, 5.67 divided by 994.67 and we get 5.7, same as the calculated value for gain. For the second value, we are using 10 kilo ohm of RF value. Going to stimulate it. So we're going to set the voltage, which is we are using 15 volt. So here we can see blue color output. We get 10.966 and slightly the same with calculated value. We out 7 volt and for gain 10.966 divided by 981.15 millivolt and we get 11, which is same value of gain that we calculate. And for the third value of non-inverting, we are using 33 kilo ohm. Going to stimulate it. So here we can see there is clipping. Same goes to inverting amplifier. When we are using 33 kilo ohm, there will be clipping on the output caused by we are using 15 volt. That is same with the same goes to inverting amplifier. Maximum resource is 15 volt. Here I'm going to explain and answer question number 3. Why is it called a non-inverting amplifier? An amplifier that produces an amplified signal at the output having a similar phase as that of the applied input is known as the non-inverting amplifier to provide an amplified signal which is in phase with the signal present at the input. The Vin phase that being entered by the graph is positive. Both Vin and Vout in positive phase. It didn't invert any of the value because we get both of the answer is both of the peak of the graph is positive, so it didn't invert any of the phase, so we call it non-inverting amplifier. For question number 4, what does non-inverting mean if a sine wave is connected to the operational amplifier plus terminal, positive terminal? The input voltage signal Vin is applied directly to the non-inverting positive input terminal, which means that the output gain of the amplifier become positive in value. As we can see through the graph, in this condition, it will not change the phase that it go through in and goes out. Both is synchronized in positive phase. For discussion, for inverting amplifier. For inverting amplifier, first we connect all the component based on the lab sheet with the AC voltage connect on the negative. Sorry. The AC voltage connect to the negative of the op amp after the R1. We will change the RF value with 3 type of value, which is first 4.7 kilo ohm, and second we are using 10 kilo ohm, and for the last we are using 33 kilo ohm of RF value. After that we calculate the gain and Vout value, and then we compare theoretical value with calculated with experimental value. For non-inverting amplifier, we investigate the op-amp used as a non-inverting amplifier. We connect all the components based on the lab sheet with the AC voltage connect to the positive node of the operational amplifier, and then we change the value of RF with 3 type of value, 4.7k, 10 kilo ohm, and 33 kilo ohm. After we have the calculated value, all the gain and Vout, we compare to the theoretical value and experimental value. After all of the calculated value are slightly the same as the theoretical value and experimental value for both of inverting and non-inverting operational amplifier. As a conclusion, I can successfully construct circuit and record all the value. We also be able to demonstrate both of the amplifier, which is inverting and non-inverting amplifier. Lastly, we are able to investigate on the clipping based on the graph and investigate the operational amplifier voltage. In class we learn inverting changes and non-inverting is non-changes. That's all from me. Thank you.